My name is Jussi, and I'm going to talk something about building geographically distributed microservices or any systems, and how containers and different related container kind of technologies help you in that sense. The favorite topic, of course, is myself. I work in a Kontena company. We build a container orchestration platform. Been working with containers since for the past three and a half years already. Went to production with Docker 0.6. Not a good idea. Did it anyway. Still alive. I guess that's an achievement. Nothing burned down much. What I'm going to talk about today, of course, is a bit why would you actually build something geographically distributed across data centers, across different cloud providers, across basically anything. What are the different solutions you can use? And then what are still some of the issues that you have to still solve? I mean, technology and the underlying sort of building blocks solve half of the things for you, or help you solve some of the things for you, but you still have to work, unfortunately. Well, I'm gonna not break the habit, so we already saw a couple of cool demos, so yes, there's gonna be a demo. Hopefully I won't burn anything down, let's see. When I did the slides, I was actually trying to find out a sort of a official or even semi-official kind of statement that what it actually means that when you have things geographically distributed. And the only thing I was actually able to find was this, which is, well, kind of not related. So I didn't actually find any sort of official kind of explanation that what it means. So what I did, I took that and made it my own. Because if you only switch a couple of words, it actually makes sense. So the arrangement and kind of setting up things where your different components of your system, your different microservices are running in a data centers, in a servers that are geographically distributed. So they can run on different data centers, they can run different cloud providers, they can run on different regions, they can run anywhere in the world and still function as one big system. Well, why would you actually want to build things that way? The first and typically the foremost reason is resiliency. I mean, as we already heard in a previous talks, and I guess most of us have seen and witnessed, and some of us had the pain when US East goes actually down. Well, even though cloud providers are really cool and everything, it's still operated by humans, and it's usually the human errors that cause problems. Another reason why what we've actually seen in the past and see constantly is this sort of a hybrid solutions where you want to run part of your workload in a cloud environment to be able to scale up dynamically and scale down dynamically. But you still have your private assets on your private data center, which you really want to still use. You have your big, let's say, some legacy big system, some mainframe, which has really important information. So you want to kind of utilize that still. In some environments, there are actually strict regulations that you have to run part of your system in a specific country, for example. So I'm living in Finland, so we do have some regulations for certain type of systems that the data cannot leave the country. But still, part of the workload could be actually run in a cloud environment. So I could run my system so that the databases and the basic data processing parts are actually running on my private data center in Finland, but then another part of the load could be running on Amazon, for example. And of course, we all try to avoid the vendor lock-in. Most of us are tied with Docker, I guess, nowadays, but that's another discussion. But anyway, with containers and sort of other solutions that I'm about to present soon, you can actually avoid vendor locking in a way that you can build your systems that actually span across cloud providers. So you can actually run your things on Amazon, then you want to switch to Google, you just start spin up things on Google and gradually shift the loads to the Google part, and voila, you're good to go. And I've even heard some startups using these free credits quite wildly, so that they use the free credits on Amazon side and start to shift to Google for the free credits. And then I've actually heard a startup that is on round 5 on that kind of setup. Yeah, well, if it works, fine. So some of the challenges in this sort of a multi-data center type of setup is of course the deployment orchestration. How do you make sure that you have something that keeps track on your services and applications, that they are really running and they are running as somewhere as they should be running? And of course, networking is kind of a pain even in application layer, because if you take Google virtual machine and Amazon virtual machine, the networking setup is completely different. So it's really something that you don't want to expose the application developers into these sort of problems. And then when your applications and systems are running in multiple data centers, how do you actually ensure the connectivity between those? And hopefully in a secure way even. You can, of course, you can, of course, build some VPNs and those sort of things, but, well, building a VPN across different clouds is kind of a pain behind, so let's try to avoid that. When thinking about this from kind of a requirements point of view, that if you had a platform that could function really well and easily in a multi-data center environment, of course, the number one requirement for that is an easy deployment for your applications. So it's really the application developers, the app teams, they don't really have to care about basically anything. They just, it's basically should be hit push and go home type of interface. Which means that the network level things should be really abstracted away. The application developer shouldn't really have to care about any of the networking stuff. Even though we are working well, most of us, I guess, are working in this sort of a DevOps type of environment where you have devs and ops mixed together, but still, I really suggest that the app developer shouldn't really have to worry about these sort of things. And then when applications and services talk to each other, it should be done securely. And by securely, I mean when service A talks to service B, and if it hops from Amazon to Google, it goes through public internet, basically. That hop should be encrypted, right? But another thing that you really don't want to expose your application developers is something that where they have to figure out how it's encrypted when the TLS certificates go old, because they go old. Well, you notice that they went old a day or 2 days late. Yep. Of course, we could build some VPNs between the different cloud providers, different data centers. But anybody building has, if anybody has built VPNs between different cloud providers, it's kind of a pain to manage and pain to set up and keep up to. And of course, there's always an option to do your DUI deployment orchestration, even with containers. But luckily nowadays there are really ready-made platforms that can actually solve most of the things for you. Because if we build these things ourselves, I mean, it's fun to build orchestration systems, it's fun to build deployment pipelines and everything, but it basically ends up like that always. And probably, even though it's cool to build those and it's really fun, well, I wouldn't work for Kontena if it wasn't fun. It's probably something that you don't actually get paid. Your company doesn't get money by building that stuff. It's kind of a extra work for you guys. I'm probably kind of preaching to the choir when talking about the benefits of containers, but well, I'm going to do it anyway. It's container camp, so I guess most of you are kind of sold on the idea of containers already. So, but yeah, containers for the win. They really allow us to efficiently use our resources, because you can sort of use these kind of traditional bin pack algorithms, for example, when you pack your servers full of containers and basically utilize every last CPU out of and bit of memory on that machine. But I think, in my personal opinion, that really the biggest thing with containers is the application portability. I can take any random container image and run it on my Mac. Well, it's running on Linux still, but anyway, running on any Docker environment. I remember I used to work in Java world like 7-8 years ago still, and like already 15 years ago they had this statement in Java world that yeah, build once, run anywhere. Yeah, right. Build once, debug everywhere. But I think containers is finally the technology that actually kind of makes that promise reality. I really can take basically any container and run it anywhere where I have Docker or Rocket or something else. And then, of course, from the application point of view, you really get these environment parodies within the container. I mean, the application, it's the same in every environment because it's the same bloody container image. And then my favorite new invented word, deployability. Deploying things with containers is super easy. Docker run something. Couldn't be much easier than that. When you want to switch to new version, Docker kill and Docker run again. That's easy. Running things in multiple data centers, the most important building block for that is a technology or kind of layer called overlay networking. And what I mean by overlay networking is it's basically a network that's built on top of some other network. And actually, when thinking about it, when running things on cloud providers, you actually have quite a lot of layers of overlay networks. How it actually works, overlay networks, and I'm not going to go too deep into the technical details of the overlay networks because I think you get better explanation on the next session. I'm going to share some practical kind of how it really works with Kontena and Weave as an example. Of course, well, those are that's the combo that I know pretty well. But of course, you could switch Kontena to Kubernetes, Mesos, whatever, and then you could switch Weave to Calico, Flannel, or something else. So what basically happens is that with container overlay network is, despite where my container is actually running on the which data center, they are always connected to this special overlay network, which basically means that every single container gets an IP address on this private overlay network. So it doesn't actually matter from the application point of view when my WordPress wants to talk to MySQL, well, it connects to MySQL. It doesn't care and need to understand in what data center MySQL is actually running. How it works kind of beneath the surface is that, at least with Weave, it utilizes these kernel-level vSwitch features that actually handles the packet routing. So it's basically done on kernel level, so it's pretty fast. And of course, it uses these standard VXLAN headers to actually make the overlay network work. And if and when you need encryption between data centers, for example, it does standard IPsec with AES GCM encryption. Which actually then means that when my WordPress connects to MySQL in another data center, the connection is actually encrypted with AES GCM without WordPress actually having to understand it. I don't have to configure any TLS certificates or anything for WordPress, which is cool because managing certificates, it's a pain. It's always a pain. So basically, that's how it looks on actual container. I'm going to show it on the demo also. So basically, your container gets a host name with some within the private network, overlay network. You get a special ETH-WE interface that has a private IP address, and then you can ping other services with just DNS names, regardless where they are actually running. I'm not going to talk about too much on the scheduler and how the geographical distribution affects the scheduling part, because I think Laura already handled that pretty well in her session. So I actually kind of deleted a couple of slides, but that's actually good because I would run out of time anyway. But what's important from the application and container scheduler point of view is that the scheduler really now has to understand the locations. Apps and containers, they have to be deployed on many locations. So the scheduler really has to understand that, okay, that node is on AZA and that other node is on some other zone. And then, of course, especially in this sort of a hybrid solutions where you have things running on your private data center, it's important that the scheduler is able to pin the location. I mean, certain services has to run only on my private data center, so you have to pin the location for those services. Yep, but what about then the services themselves? I mean, now we have kind of the infrastructure things in place. We are using containers. We have the overlay network that's spanning across different zones and data centers. But I guess we still have to worry about something on the services, on our applications, on our microservices. Of course, always when you talk about microservices, you cannot really go past Conway's law that any organization that designs a system and blah, 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 yeah, well, we are running things, multiple things on multiple different locations, multiple different servers. So throw Conway's law out of the window. It doesn't really matter. There's really something more important, and it's Murphy's law. Anything that can go wrong will go wrong. And now when you're running things on multiple different zones, data centers, servers, you run multiple different services, applications, containers. I mean, it's like an exponential curve where, on the probability of things going south. And my personal experience is that in this sort of a setups, when things go wrong, they usually go wrong on public holidays. I don't know what it is, but it just seems to be the fact of nature, at least in my life. A few years back, we were running this sort of a setup with containers and with Docker 0.6. And we had 3 major breaks in a year: Christmas, Easter, and Finnish midsummer. Great. On the service level, you still have to kind of you have to still yourself figure out how your application and system behaves in the sort of a cap theory way. How does your system handle split brain, for example? And now when things are running on multiple different data centers and cloud providers, there's going to be network glitches, for sure. That's kind of something that's guaranteed in this kind of a setup. Something's going to break. There was actually a couple of years ago in Finland, there was somebody with an excavator cut down a bunch of fiber cables. And that basically kind of split the Finland to different portions. And you guess how many split brain syndromes we had during a single day. That was a fun day. From the application point of view, it's you still have to worry about a lot of things, yes, but quite a lot of things are easier now for you, because your application doesn't care about the infra at all. They are in a container, they get the networking and everything set up for them. Cool. Especially cool because on the application level, you don't have to worry about the encryption. I'm kind of emphasizing on that because, well, in my personal history, I had to build a system where every single component, when they talk to another component, had to be encrypted. So we had like 7,000 point-to-point TLS connections, which was really, really painful to manage. And then the location is really abstracted to a degree. I mean, you still have to figure out the latency issues, for example, because when you hop from Amazon to Google, there's going to be a latency, of course. And when things are encrypted, there's going to be a penalty. So it's not going to be super fast. It's decent still, the connection, but it's not super fast. So on the application level, my kind of advice for this sort of environment is that use circuit breakers or any of other these sort of what do they call service fabrics, for example, like Istio, and if you're in Java world, use the Hystrix from Netflix guys or something similar, because that really protects your applications from these sort of cascading failures, for example, and really help your life a lot. One thing that's kind of feels kind of stupid even to mention, but don't really cache the DNS results, because things move around by the schedulers, whether it's Docker Swarm or Kubernetes or Kontena. It might reshuffle your containers to different IP addresses and different locations and whatnot. And it's actually surprising that how many applications, when you configure some, let's say, database connection with DNS, when the application starts, yeah, it figures out the IP address to DNS, but then it kind of holds on to the IP address as long as you go and kill the application. So it's like, come on, it's 2017. We should know better than that. But it's surprising how many applications actually do that. And then one of the kind of biggest things that you really have to plan and have to figure out is the consistency model of your system. Because that's really important to understand and whether your system can actually recover from a split brain, whether you employ these raft algorithms and other consensus kind of ways of doing things, or if it's eventually consistent, or how you build your application. Because that's really important. As mentioned, things will go south. That I guarantee. If they don't, I'll buy you a beer. And then really, really important is to utilize chaos engineering. To really test out all the possible cases, unplug the cables, shoot down servers randomly, do anything you can imagine to do to your applications and servers. Because that's really the only way you can actually find out the different scenarios, how things can go wrong. And that helps you when things actually go wrong in production, well, you actually know that, okay, it went wrong this way, I know how to fix it. Because when things go wrong in production and you don't actually know how to fix things, then it's bad. At least the stress level goes through the roof. One good example or practical guidance for chaos engineering is, for example, we run most of our stuff on CoreOS. On our clusters, we typically utilize a couple of nodes that are running CoreOS beta or even alpha channels. So they update quite frequently. And well, it's beta and alpha, so things break down. So we have basically automated chaos engineering in our system because they reboot randomly and update things to non-working states. So that's pretty kind of easy way to have chaos engineering in your cluster. Yes, demo, please. Let's see how it goes. So for the demo, I'm going to utilize Kontena as the orchestrator, and just going to show a couple of quick things. Is the font big enough? Yep, okay. So what I have in my setup, I have 5 nodes running on actually 3 different locations. 3 of them are running on packet machines on Amsterdam. And then a couple of nodes are running on DigitalOcean in 2 different zones. So I have basically 3 different locations on my setup. I'm going to create a really, really stupid service, Nginx. And the point that I'm making is that the scheduler really has to understand the locations. And in this example, I'm instructing the scheduler to build or deploy things on highly available manner. So basically spread all my containers across multiple different AZs. And as you see, I've labeled some of these nodes with the special AZ label. So that's something that the orchestration actually kind of understands. So this is pretty much what was used in the swarm also with the placement preference flag. So yeah, let's see how it goes. So basically, Kontena should now take care of 3 instances of spinning up 3 instances of Nginx for me and spread those in 3 different zones. And if you compare the node names, so Twilight Lake 92, it's on packet Amsterdam 1, Sparkling Meadow, DO Amsterdam 3, Nameless Field, DO Frankfurt. So it worked. Cool. And then I'll take a terminal session to a random other containers that I have running. So my Kibana, which is just something that I had in running, don't ask me anything about Kibana, but if Kibana would actually like to connect to the just deployed Nginx, Kibana shouldn't really care where Nginx is running and how it's running. So what it can actually do is just go through DNS. The client doesn't really care where it's running, how it's running, in what location, how the networking is done. I didn't have to configure anything about the encryption for the kind of client application. Yep. Yeah, well, there's a special interface in the container called ETH. WE, which then handles all the magic behind the scenes for your application. If you're more interested in Kontena, it's fully open source stuff, what we're building, so go and check it out. I'll be hanging around here all day, so if you want to have discussion, just feel free. Thank you.